My name is Raja Shembekar. I'm the PACCAR Vice President for Manufacturing. Prior to PACCAR, I worked at Denso for 18 years, and part of that was 2.5 years in Japan in their advanced manufacturing center. And then prior to Denso, I worked at Ford for 12 years. So I've been in the automotive industry for about 31 years. So before I go into my journey, explaining my journey with KCF, please allow me to introduce you to PACCAR. So I have a 2-minute video to share. Great, thank you. So I was always a car guy, but after I saw this video, I said I need to get to the truck side. So anyway, so PACCAR is a global commercial vehicle manufacturer with sales of 2021 revenues of $23 billion, with revenue of $1.85 billion. I think the key point here is that PACCAR is a company that has had profitable years, 83 years consecutive. So it's a pretty amazing record, and a dividend that was paid every year since 1941. So PACCAR is made of 3 areas, 3 divisions: truck, parts, and financial services. So, going with the, okay. So before I go through the journey with KCF, let me start off where I started. So in 2017, there was a conference. There was a conference in San Diego called Industry of Things World Conference. And at this conference, I really started to understand the power of IoT, the IoT stack, and the power of data. IoT was a buzzword in 2017. People were still learning it. But having a robust data source is critical. Without having a robust data source, there's nothing. And so at the conference, one of the gentlemen came up to me and said, hey, you might want to talk to a company called KCF. And that's how I met Andy. And so Andy and I met in beginning of 2017 and in Denso. And after listening to Andy, I realized the power of the technology that KCF brought and the capabilities and the business model. And so I was convinced that we really need to do a POC with these guys to validate. Andy is a sales guy, so he obviously was doing a great job of it. So I needed to make sure that I validate what he was saying. And so we started a POC at Denso. And then in 2019, actually, when I joined PACCAR last year, I was really thrilled to hear that PACCAR was also working with KCF starting in 2019. But I'll go through some of the use cases with PACCAR in my later slide. So my aha moment, right? So this was in 2017. We had just started the POC with Denso, and let me explain the POC before I go into the point where I really realized the power of this technology. So at Denso, we had these braze ovens that had 9 recirculating fans. This is actually a screenshot of the KCF sensors labeled 1 through 9. And these brazing ovens, these recirculating fans are very expensive. They run in a very high temperature environment, over 700 degrees centigrade. They run in a very dirty environment with powder flux that cakes the fan blades and the cage. And so invariably they would fail, and when they fail, they would have a very big impact on production, almost $70,000 per day. So it was huge. And we had 12 of these furnaces, each one of them having 9 recirculating fans. So you can imagine 2 or 3 of these failures a year, that's a few $1 million that we would have to suffer. So this is a photo of the recirculating fan with the KCF sensor attached to it. And the moment that really struck me was I like to really understand the technology very well. I like to get into the weeds, so to speak, because if you do, then you really understand the technology, and then you can understand how to apply it from a strategy standpoint long term. And so I used to go into this dashboard every day and start to understand what it's trying to tell. And in June 2017, I'm looking at this, and I said, hey, there's a upward trend there that does not seem right. And we had set up these parameters or these warning process controls with the help of KCF. And I looked at this and I said, this does not look right. And so I called KCF and I said, hey, do you guys think this is a problem? And they were really, you guys obviously know KCF. They looked at it and they said, yeah, you need to have the maintenance look at the fan because that is a problem. So I contacted the maintenance guys and said, hey, here's the dashboard and it's showing a trend that does not look good on one of the recirculating fans, so you might want to check it. And they looked at me, here's this executive, he doesn't know maintenance, he spends time in his office. What is he telling us about this? That's crazy. And so they basically said, the fan was already cleaned, it's fine. We'll keep monitoring, we'll take a look at it. And I looked at it and I said, no, that's, based on what KCF said, we really need to look at it. So I insisted that they did that they check it out. And on the weekend, they did check this. And what we found was, here's a picture of the actual fan. And they were actually, the fan condition that was this was not the one that they had cleaned. And they went over the weekend and looked at it, and they had so much debris collected over the fan that it's probably going to result in an imminent bearing failure. And again, as I said, it was a huge impact. So when they did that, it was really a turning point. That was a point that we both realized that, the power of this technology, the power of the data, and having it in real time and continuous, that's IoT. As Jeremy said, we had all sorts of spreadsheets, right, in the past, but that's just historical data. What KCF did here is provide real-time, continuous, live data. That's IoT. And so this was really amazing. So I still, when I was preparing for the slides, I told Andy, I said, Andy, can you send me that slide again? That kind of made me realize what the power of this technology was. So that's really what happened at Denso. But it wasn't without struggles. So every new technology, every new disruptive technology takes a lot of effort, takes a lot of collaboration. And so the first thing that we struggled with is belief in the data. So we had this dashboard, we had all the data that we were getting, but it was the first time that we were getting live data that shows the condition of the fans. It was hard to believe that this data is accurate and that we should believe in it. And so a big part of my time launching this POC was really to make a believer of this data, and that we can believe this data and we can take actions off of this data. The other one was the maintenance culture and mindset change. So they really, it really took, I think the biggest challenge for me was really this point, is they were maintenance experts who had 30 years experience, and I respect a lot for who they are and what they bring. But here is a technology that is disrupting. Here is a technology that is not traditional, and it's really providing very effective means of condition-based monitoring. And so it was really a lot of effort on my part, on my engineer's part, to really change the maintenance culture and the mindset that you should believe on this data, you should take action on this data, and oh, by the way, that action needs to be in real time. It cannot be at the end of the shift, cannot be at the end of the week. You have a problem, you see it, you need to take action. So that mindset was really, really important. The third one is a disciplined and systematic approach. So, and this is something that I've learned over the past 8 years working with different technologies, is you really need to get involved and have a systematic follow-up. It has to have a cadence where the right people get to the team, the right people share the data and discuss it, because everybody's learning. So it's really, really important to have a disciplined approach to make this work. And the last one is the executive involvement and leadership. So when we were doing this, I was the vice president of the Denso North America Innovation Center. And with all the other things going, I really felt that I needed to be at the ground level and really support the team, because the engineers who were doing this understood the problem. They understood the pains that this can cause. Maintenance understood it. But it's really important that executives at the company also support this strongly. It is really a point that would support for scalability. So executive involvement and leadership is very critical in this. And these are some of the challenges that we had initially. So in the past 6 to 8 years, I've worked with, as I said, several different startup technologies and different disruptive technologies. And I've brought together these points that I believe are really valuable to use for evaluation for any technology, not just KCF technology. The first one, some of them are pretty straightforward. You can understand just by reading, but I would just like to go through this very quickly. So reliability is really important. If you have a sensor that you are depending on and you're expecting live data, imagine if that sensor stops working. There's no value. And so reliability was very, very important. Without reliability, there's nothing. If you look at the success of many of the products in the marketplace, they're successful because of reliability. And actually, the next speaker from Toyota, Suzanne, Toyota is known for reliability, right? That's the key. So that's really important. Reliability of the product is really important. Maintainability is also really important. And what I mean by maintainability is, if you have a product that requires an army of people to maintain, that value, the business value really doesn't add up. For example, if I needed a software engineer to manage the KCF dashboard, well, that's additional headcount that I'm now deploying just to manage the dashboard. Or if I need to have a lot of people to support this technology, it really is counterproductive. So that's what maintainability is. Usability is also really important. How easy can you use it? How quickly can you use it? If I have to spend 6 months in training somebody just to use it and understand the data, you're going to lose the value. You're going to lose the interest. You're going to lose the motivation. And so usability is really important. Scalability, as Dr. Frank said, scalability is really, really important. Sometimes we go look at POC, and it's a really myopic view, right? You look at it and say, oh, yeah, that worked really well there. And we forget the long-term view. It's really important that whatever you do, in whatever POC you do, you always have the long-term view in front of you. And if you cannot scale, then you're not adding value. You're not adding business value across your enterprise. Speed of deployment, again, was discussed earlier. That is, I think, the most important thing. I mean, obviously, all these are important, but speed is so important, because if you're going to take years to get value, you will lose the interest of the top management. You will lose interest of maintenance. It has to be quick. One of the things on the Denso POC is it literally took us, I think, 5 or 6 days from when Andy came in to when we had data streaming. That's fast. I have had salespeople come to me and say, hey, I'll get you data set up in 36 hours, you'll have data streaming. And I said, well, if you can get me to have data streaming in 36 hours, you got my business. Very few people have been able to achieve that. So KCF was able to get this data up and running within a few days, and we were actually, within 2 weeks, we were starting to look at trends. That's fast. That's speed of IoT, in my opinion. Security of data is really important too. You can imagine, you've heard a lot of the ransomware, malware, viruses that affect. If you have sensors that are connecting, luckily the way the KCF works with cellular or Wi-Fi or BLE, it really doesn't impact your OT systems. But if you do, you really need to be careful that the data cannot be hacked. And also, who owns the data? it's really important. That's the data is the new oil, right, as everybody has heard. So it's really important to manage that data. And then, of course, the total cost to get the business value. So these are not in any particular order. I really encourage people who are doing new technology to utilize this based on the use case, based on the technology. So coming to PACCAR, I really wanted to share this because in PACCAR, I was so excited to see the team do so many use cases. They're already, the speed that I talked about, they're in the speed of lightning. They're moving extremely fast. Really thrilled to hear that. And with so many use cases, so we actually established KCF sensor as a PACCAR North America standard for vibration, temperature, and some of the other modalities that we would like to monitor. And we're also evaluating it for other regions outside United States, so Australia, Europe, things like that. And they actually got an award from KCF recently, the 2022 Automotive Industry Award, for all the effort that they've put in. Some of the folks who are on the photo, I think, are here today. So really great to hear that. Congratulations to Kenworth. Kenworth team has already had over 289 sensors deployed in a very, very short time, and many successful use cases. And as I said, we're also evaluating global deployment. These are two use cases that I got from Jacob from Kenworth, and he's really the person leading it. The left side is really a use case for a paint oven. So paint ovens are very, very important in a truck assembly line. They are the way the customer perceives the quality of the product. And it is very expensive, and so it's really important. So on the left side is a use case where you can see the normal condition of the motor. And actually, this is very interesting. I put this use case because there was a problem that actually the way the manufacturer had installed this was incorrect. So it was not about condition-based monitoring from an ongoing perspective. They actually found the root cause to be a manufacturing defect from the supplier. And when you can see some of the preloading that caused the bearing to fail and the fretting on the right side of the photo. That to me was very interesting, that they actually got the root cause of actually the installation of the equipment was wrong. And I think the last bullet point, they avoided a significant downtime and also cost associated with it. The second example to the right is also a chiller pumps, and you can understand this pretty straight. I think it's a strainer there. You can imagine that the strainer gets clogged with debris. Your delta P changes, and you're going to have cavitation to the pump. And everybody knows that's not a good thing for the pump. So these are two examples from PACCAR. There's other examples that Jacob and his team are doing as well. So I won't go through the detail, but these are just some examples. The thermal oxidizer for fan alignment, they've already had several avoidances of downtime. The air supply fan for the paint and the last one they're still evaluating. But the key here is really the speed, understanding the technology, and then learning from the technology, and then really to drive the business value. So we continue to see a lot of applications throughout PACCAR. And then the last slide I have is it's something that I've talked with KCF in the past. I continue to get feedback from them and understand the technology with their experts, but I think batteryless sensors are really important on the future. Energy harvesting is really the key. As you can imagine, as your company grows and we continue to add more and more KCF sensors, every one of them does have a battery or it's powered. And if you have a battery, you need to change it eventually. And if you have thousands of them, that's labor for me to go and have these guys change the batteries. So in the future, I think it's something that we should really look at. Built-in analytics black box. So this is where it's a plug and play. I can connect a box, and it has got a data analytics, so to speak, built into it. You have the data already streaming, you get the data, and you can really get to the next level faster. The last one is non-contact wireless sensors. So I think this is also a technology that we would like KCF to investigate. So if you look at machines that are moving, rotating parts, you can't necessarily apply the KCF sensor to it. Maybe you can to the surrounding, but not to the rotating part. So this is maybe another area that I would encourage to really consider. And then increase the capabilities to other modalities. So I can see I've got 19 seconds left, which is perfect. That's the end of my presentation. So thank you.
All right. Thank you, Raja. Right on time. Something Raja did not mention during his presentation, but he was telling me earlier today, and I thought this was great. Raja, he kind of spans this world between the executive office and the shop floor, where you have to earn buy-in from both, right? Well, at Raja's company, when you're part of the executive team, you have to wear this every day, right? You got to wear a tie. And sometimes...
The Packard people know that.
Yeah, the Packard guys are familiar with that. True. But sometimes even the way we dress might drive a little more of a chasm between executive and shop floor. Funny side story, I was at your Chillicothe, Ohio factory not long ago with one of my colleagues, Steve. Steve had to put some sensors on a machine on the shop floor. Steve shows up. He's got on a pink polo shirt, like nicely starched, and Italian leather loafers with no socks. And he's like prancing around the shop floor, putting sensors. I'm thinking, this is just out of place, right? This doesn't feel right. But meeting with your frontline maintenance professionals, they were all bought in. So the question is, how do guys in Italian loafers and guys in ties continue to earn that enthusiastic buy-in from the shop floor? In your experience, what has really made the difference?
So really good question. If you think about it, what do production people and maintenance people want in life? Day-to-day, normal operating condition, right? What are we trying to do? Disrupting it. We're doing exactly opposite of what they're working every day to do, which is have a stable production and have all machines running. So I think the only way to really bridge that gap is have the data show to them that it actually helps them. It provides relief to them. Nobody in maintenance likes when machine goes down and you got a call and everybody's breathing down your neck to get it fixed right away. When you have technology like this that can provide them advance notice of failure and can have predictive failure, you can imagine their life becomes so much simpler. Nobody would say no to that, right? So that's the way to bridge that. Then the clothes don't matter, it's the data.
The clothes don't matter, it's the proof. Yeah. All right, let's hear it for Raja.
Thank you.
Thank him one more time. Well done.
Thanks.
Thank you, Raja.